Today, we're going to be assembling and rigging an offset Robotics Nano-Lift straight from the box. Here are the bags you'll need to assemble your Nano-Lift. The Nano-Lift is assembled sequentially, so we start with the smallest stage, assembling each insert as we go, and once the tube's done, we'll then attach the mounting, which is these bags here. So we'll put these to the side for now, and we'll be working with just these bags and these tubes. We'll start off with our 10mm stage. You'll find a 10mm bottom bag which contains everything you need for this. On the 10mm tube, you'll find that one side has 2 holes and the other has 4, one per side. So the one side with only 2 holes will have our mounting block on it, which you can use for mounting your end effector. And on the other side, we have the holes for mounting this 10mm insert, which will run along the inside of the 20mm stage. These are both custom machined and very strong. You shouldn't have any issues with them breaking. To fix both of these, you'll be using 10mm M3 screws. You'll notice that on one side, there is a hole higher up to the edge of the aluminium, and this one's a bit lower down. Now this hole will be used for tying the cascade extension string to. This is the one we'll use for mounting. Our next step will be this bearing assembly here. You'll notice there's 2 holes here, and then you've got one space here for the bearing. So you'll have a bearing there, a bearing here, and then a bearing on either side of this piece, one here and one there. For the top bearings, you'll be using 12mm screws, and for the bottom bearing, you'll be using 10mm screws, which you'll notice are slightly shorter. We'll start with the top. Screw, then bearing, through to the other side, another bearing, and then a nut. Now, for the side bearings here, it's important to use shims on either side of the bearing, that way it can't catch on the aluminium. Put the shims on either side of the bearing like that, and then just slot it into place. One side will be threaded and the other side won't. For me, the threaded side is that side, so we then pass the 10mm screw through and into the threaded side like that. And then repeat on the other side. Perfect. Now we'll put this aside, but we will need to come back to it very soon to tie the return string off, which has to be done before you assemble the rest of the tube, or else it'll be a massive pain later down the road. Our next assembly step will be the 20mm bottom stage, which will run along the bottom of the 30mm. This insert is composed of 2 plates and a 3D printed insert in the middle, which will then be attached with screws. To do this, put one screw all the way through, a bearing, the insert like that, a second bearing, then repeat on the other side. And finally M4 nuts on the other side. You'll feel that the bearings can roll smoothly. We then place this inside the tube. Tolerances should be tight, but not too tight. You'll see that the holes now line up. We're going to be fixing this in place with these 2 holes, not to be confused with these ones. These will be tying off our extension string. This will require a little bit of force as we are threading the 3D print. Perfect. I've put one M3 screw on either side. Now these bearings are the side bearings that will roll along the 30mm stage. However, we'll put them in later as they fall out. Perfect. Now, before we go any further, we want to tie the return string to the bottom of this stage because it's going to be hard to access once the whole tube's assembled. The return string will pass through this stage and then attaching to this here. So to do this, we'll grab out of the utility bag all the string. you'll find one shorter and thicker string. This is 1.5 mil, and we'll use this on our Cascade extension string. And then you find two pieces of 1 mil string, which are the same length. Grab either of them, and what you want to do is pass it through the 20 mil bottom stage, like that. And then you'll be tying this off to this insert here. We'll just go through the hole, out the other side, and then we'll just tie a knot. Make sure this knot is very tight, as we won't be able to access it once it's tied. Perfect, and I would even add some super glue to make sure it doesn't come off. Like so. And now you can cut off any excess. Like so. Perfect, and now we're going to put the 10 mil stage inside the 20 mil stage. Now, one thing to note. We're going to be tying a string through this hole in the 10 mil stage. That means that we have to be able to access that hole through that access hole. So what I'm saying is just make sure these two are aligned. So now we've got the stage and then the return string here. Our next step in the assembly is going to be assembling the 20 mil top. And you'll find a bag for it. First things first. You'll notice that these plates have an indent in them. That is for this bearing and dowel assembly, which will run along the tube. So we now need to put the 6 mil M3 screws through the plate and through the tube. Now this next bit may be a little bit difficult. You'll find these tools that were in the utility bag. These are for putting nuts on the other side of these screws. Now, in order to screw the screw into the nut correctly, what I would do is first remove one of the screws, but leave one in place. Like that. So you can see all the way through. I'll then get our tool, slide it through the access hole on the side, until you can see all the way to the threads of the nut. Which means we've now got a clear path for the screw. So we put the screw in, then just tighten it down. Just like that. We can now gently remove the tool. Now we'll rinse and repeat for the other 3 holes. Perfect. Now, the next step will be mounting our bearing assemblies. Now, for the bearing assembly, on one side, we'll use this 3D print here, 2 bearings, and the 2 plane spaces, like that, and the rest will be for the other side. So to assemble this, nice and simple, bearing, bearing, spacer, spacer, like that. Slide that into place. Screw all the way through, like that. Easy. Flip it over. Now there might be a little bit of a gap here. To fix that, just like run the tube up and down like that till it's flush with the bearings. So ready for the next assembly. For this one, we're going to be putting our bearings on these 3D prints here. Like so. And then it's going to be assembly, bearing, assembly, just like that, and then screw through all the way. Next, we'll use the M3 nylock screws to tighten this in place. Now, the tightness of these screws will affect how smoothly the tube runs and how much play there is in the end. So, right now it can feel a lot of friction, so I might loosen them a little bit. just have a play until you're happy with the level of friction. So now we've finished the 10 and 20 mil stage, and it can run smoothly, do any adjusting that you might need, and make sure to check that you can see that hole through the access hole, and that's going to be very important for rigging it later. Okay, now that the 10 and 20 mil assembly is finished, we're going to be putting this 20 mil stage inside the 30 mil stage. Now, 3 things to note. 1, when we're putting them together, we want to make sure that these access holes and these access holes are aligned. That way the plates are on the same side. 2, we're going to need to thread this return string all the way through to the bottom, and just be careful because it does get kind of caught on the pocketing, but it's not too hard to just slowly work it down until it reaches the end like that. We want to pull it all the way through, like that. And our third and most important, please make sure that these bearings fit in here before you slide the whole tube in, because it's very, very difficult if you forget this step, you're going to have to disassemble the 30 mil top to fix this. Perfect. We provide a 30 mil top bag. Now it'll be a similar assembly where you have the plates with the indents for the side bearings like that, and then you'll have everything you need for the middle bearing assemblies. We recommend you use the zip ties we provide in the kit to fasten these bearing assemblies in place. Now we'll mount the plates in the exact same manner as before. Now if your 3D printed tool breaks, feel free to print more. Like so. Next we'll be constructing the middle bearing assemblies. Now the orientation of these are important. So you'll notice on one side we have a V-groove bearing for the cascade extension, and on the other side we don't. Now we want to reverse that. So on the side that doesn't have a V-groove, we want V-grooves. And on the side that does, we don't. For starters, we'll take this 3D print here, 2 bearings, and then 2 spacers like that, and we'll just stack them together. Like so. And then we'll place that here and run a screw all the way through. Just like that. Now again, we'll press this stage down so it's flush on the bearings. And now for the next assembly, this is the one with the V-grooves in it, and it's for the side that doesn't have a V-groove. We'll use all the remaining parts. These 3D prints will have a bearing on them with a spacer on the other side like that. And then we'll have our V-groove shield with shims, and these will be for fastening either side. So how this assembles is we first put on this 3D print stack, slide the screw through. We then have our V-groove bearing assembly. This will be tricky. When you're at this stage, I recommend using an Allen key to create this stack, which will be shield, shim, V-groove, shim, shield. It's quite finicky, so I would go like this, slip a shim into place, then a V-groove, then the next shim, just like that. Now we'll use that and slide the screw through. Now you'll notice that these 3D prints have an indent which will align with the bearing shield, make sure they're in the correct orientation, or the width of the spacer will be too much and it'll be like pushing on the plates. Just like that. Now we'll put a nylock nut on either side. Again, you can adjust the tightness of these to get the right friction. A reminder that there is a trade-off between the play of the end effector and friction. So the tighter these screws, the less play you'll get, but as a result you'll also have more friction. Perfect. Once you've got your Nano-Lift assembled, give it a play, see how the friction is. You can extend the tube fully and then pull it in with the return string, like that. Just adjust it. You can use WD-40 if you are still concerned about friction. And just give a feel for get a feel for the play in the end effector as well. It should be pretty minimal. Next, we'll be assembling the mounting and then reading the tube.
Thank you, Josh. I'll take it from here and I'll walk everyone through putting the mounting plates, mounting parts, and attaching everything to the box tube so it's finished like this. The Nano-Lift also includes all parts needed for stringing, which I'll go over as well. There are a couple of ways you can string the Nano-Lift. One way is to do it exactly how we've got here, which is an extension string and a return string. So as you can see, as I move the Nano-Lift, the spool also rotates. If you're using the Nano-Lift to lift your robot off the ground in the decode season, then it might not be necessary to rig a return string. In fact, I would recommend for most teams, rig the extension string and use magnets on your base plate, or for example, a servo that holds in your base plate instead of a return string. And the reason is because adding a return string complicates the stringing. It makes things slightly harder to access. And with just an extension string and a latch or magnet, you can guarantee that the stringing will be reliable across multiple matches. Now, of course, the Nano-Lift can be used for more than just the decode lift. For example, if you think about a Techno-Z type arm from last year, having a return string can be incredibly useful in such a situation. So I'll go over that first. For anyone who's not interested in making a return string, skip to later in the video. So to get started, here's what is included in the mounting part of the Nano-Lift. Just a note, each Nano-Lift only uses 2 V-bearings and shields per kit. So if you ordered quantity 2, we'll likely ship only 1 of these bags. So I'll get started with the return string plates. If we open up our string parts and spool plate, you'll see we've got the spool, which we'll leave for later, a few 3D printed parts, and of course our 2 return plates. Now, these return string plates are actually optional, and I'll go over that now. With the mounting plates, you can mount them in multiple configurations. So you can choose to have them at the front of the tube, in the middle of the tube, or at the very end of the tube. If you choose to mount your plates at the end of the tube here, then the mounting plates already include 2 holes for the return string to go. And now this is more similar to a regular box tube kit. As you can see here, we've got the mounting plates and mounting hardware mounted towards the end of the kit like this. So if you choose to do that, then you can ignore this step. In this tutorial, we're going to mount it somewhere in the middle, like here, for example. Then if you want to use a return string, you need to reroute this plate so that the return string can go from the bottom and then up and then through to the spool. So we'll get started with that. From your mounting fastener bag, you can see we've got a lot of M3 6mm screws and then also thin nuts. Mounting to the tube, we'll always be using these thin nuts and M6 screws. And the thin nuts are very important because it ensures that these nuts and also these screw heads don't hit on the nuts that we use to mount directly to the tube. Again, the direction in which you rig the return string is very important. As you can see, one side of the Nano-Lift will have a pulley on it and the other side will just be supporting bearings. It's very important that the return string goes through the tube and wraps around this way, and the spool is on this side, the side with the V-bearing. So taking a look at the plates here, we're going to mount it like this, and obviously the holes will line up. Because it's close to the end, you can use your finger to hold in the M3 thin nut. And again for the other side. And then making sure that those are tight. So the next step is we're going to actually use these 3D printed parts alongside our bearings and bearing shields to redirect the string back towards the spool. For this, we'll need 2 shims, a bearing shield, and a V-bearing. And this is very similar to the assembly we did for here. So I'm going to replicate it the same. I like to build it on an Allen key like this. So shim, V-groove, and then slot the second shim in there like so. Sort of use the Allen key to help direct where that shim is. Chuck another insert, and then from there I'll try and push it on. I can take the Allen key out and then line it up nicely. It should be nicely tolerant so you don't have to undo any of these screws or nuts or anything. Just chuck your long screw through Because of the nylon patch there'll be some extra resistance that you'll feel. And of course, chuck one of the provided nylocks on the end. There we go. And then position the bearing shield so that's facing upwards like this. Exact same thing with the other assembly. And as you can see, we're finished. So I like to straighten up the bearing shields like this. As you can see, they really should be pointing outwards. And now that's done, we're going to thread the string through the bearing holes like this. Out to the other side, and then pull it through. So what we've effectively done is redirected that return string, as you can see. Okay, on to mounting. So whether you use or you don't use a return string, this part's all the same. So we're going to grab our mounting plates and notice how there's a little divot on the mounting plates, and also know how the mounting plates are mirrors of each other. For this case, we're going to take one of our mounting plates and attach it like this. The straight side is pointing towards this end, and then the sort of slope side is pointing towards the return string. And the logo, the Offset Robotics logo, should be on the outside. And same thing as before, we're going to use the nut tool alongside the thin nuts with our access holes to place the nut in the right spot. With the nut in there, we're going to sort of get it through that. I'm going to get it through this access hole, just like that. Line it up, and then take a 6mm screw. There we go. Now it's just repeating the same thing for the 3 other holes. And yeah, you can always access the nuts through the side of these holes with another tool, just hold them in place or anything similar. And while we're here, we're going to attach our square beams. So this is what this indentation is for. I'm going to attach the square beams like this. You'll need a 2.5mm Allen key, and this is using 5mm M4 screws. And as you can see, these square beams are ideal for mounting the Nano-Lift, and it's actually designed to be mounted to a drivetrain plate. So if you mount it directly to your outer drivetrain plate like this, you can screw with 4 screws from the outside, and that means you can actually hot swap Nano-Lifts or take them out and replace them really easily. Alternatively, there's a bunch of other mounting holes that you can use with gussets. We recommend the Offset Robotics mounting gussets as well as plates, but you can really do it however you want. So now what we're going to do is we're going to rig up this cascade extension string, which is this 1.5mm diameter string that's shorter. It's actually 450mm. This is our other extension string, which goes to the pulley. And both the strings that go to the pulley are 1mm in diameter. And that's because quite a small pulley, having a thinner string reduces the wraparound and hence maintains a more accurate string tension as we spool and unwind. Starting with the cascade extension string, we're going to fully extend our tube. As Josh mentioned before, your access hole on 20mm stage should line up with a hole to thread the string through for the 10mm stage. So what we're going to do is we're going to ensure that this V-bearing is pointing upwards, and we're going to thread the string through this hole through to the other side like that. And we're going to tie a knot on the side that is opposite to the V-bearing. Now that's very important, and you'll see why in a second. So I'm just going to tie a regular 1/2 hitch. Try and have it so that the knot is as close to the end of the string as possible, like that. And then we're going to pull it tight. What we're going to do is go ahead and thread it back through the access hole like this and underneath that V-bearing. For me at least. There we go. Got it. Pull all the way through. And then we're going to pull it down to here. After we've done that, what we're going to do is go ahead and fully retract our Nano-Lift like this. And we're going to tie this string to some place on this tube. Now I'm going to use the square beam here just because it's a nice and convenient way of doing it. And I'll actually use another zip tie from our utility kit. So I'll do the zip tie up as loosely as I can for now. Make sure everything's retracted and that this string is fully taut. Your string will be the same length as mine, so it should look similar to this. And then pull it as tight as you can without extending that 10mm stage. Make sure that's all the way in. And then that looks good. And we can tie a knot here like that. Just do one more half hitch, push it all the way in, and we can tension this zip tie as needed later. I'll leave it here for now. This is relatively good tension, and I'll cut the zip tie head off. We'll cut this off later, but I'll recommend leaving it on just for now. And now, as you can see, when I pull the 20mm stage, the 10mm stage also extends. All right, now that we've done that, we can tie the extension string on the bottom part of the 20mm stage. What we're gonna do is, on the side with the V-bearing, of course, we're gonna take our 1mm string, thread it all the way through, out to the other side, flip it over, and we're gonna thread it back through itself until it comes out the other side. You can see we've got this. All we need to do to tie it off is to tie a knot between the two. A really good tip here before we move on is to just use a dab of super glue on both of these knots. And that's just gonna ensure that the knot doesn't come loose. So you've actually, I guess, permanently bonded the knot shut. Now lastly, now that we've tied that knot, we can thread it back through the same as before, through this V-bearing like that. And this will go back to the spool as the extension string. We've strung everything up. As you can see, we pull the extension string and it extends. And same thing, we pull the retraction string and it all retracts. The last thing we need to do is actually attach these extension string and retraction string to the spool itself. Now I will admit this is the trickiest part of the Nano-Lift build, this step. So what I'm going to do is I'm going to pop in that bearing to the mounting plate like this, and it should be a very tight press fit. So as you can see, we've got a black PLA printed pulley. There's a hole here which comes out on the outside. Now this is for the return string. You'll notice how one side is twice the diameter of the other side. And for the extension string, we're actually going to need to drill our own hole, and that's just because drilling in this case will give a better surface finish than if I 3D printed the hole in place. Because we're using 1mm string, I'm going to use a 1.5 or 2mm drill bit, and I'm going to drill a hole opposite the hole for the return string. So I'm going to flip it 180 degrees, and then quickly drill out a hole. I'm going to get my axle and put it in here, and it's going to go like this. So yeah, if you have a servo holding it in place with the Go Builder adapter, then this won't free spin and it makes it a lot easier to string it up. So notice that the retraction string, which is the bigger diameter string, is facing towards me and the extension string is facing away from me. This order actually doesn't matter, but I found that it's easier to have the extension string facing away from you, so towards the plate that you've already assembled in this build. So first things first, before I even put the string in, and again, you can do this if your servo's on, you can do this without the axle. What I'm going to do is I'm going to thread my 1mm string through the hole that we drilled. Now this is tricky and it's probably easier to use a set of needle-nosed pliers and try and get it in there. There we go, managed to get it in. And we're going to put it back on the spool here. So it should look like this. You should be able to pull it through that hole quite a bit. And what we're going to do is we're going to spin counterclockwise like this. So just about there, so that you can see the hole is facing upwards. And then you're going to push the box tube down and then pull this string as tight as you can. And then once I've done this, I'm going to do the same thing we did for the 10mm string. And I'm just going to tie a half hitch. So you don't have to be precise here, it doesn't matter. As long as you're not tying the knot too short. So you can see I've tied a preliminary knot. I'm going to go back and check that I haven't kept it too short. So as you can see, I haven't. And what I'm going to do, just because this knot is quite sensitive, you don't want this to come undone, is I'm actually going to double up this knot or triple this knot. You can see I've done a big old triple knot here, and that should stop the string from escaping back. And now that you've done that, you can cut the string. Close to your knot, I would try and leave a little bit of room just in case you need to undo the knot and redo it again, but that should not happen. There we go. And this is where having a servo really helps. From here, we've tied it off like this. What we're going to do is we're actually going to extend the box tube fully. You can do this by rotating the spool, and as you can see, it wraps around itself like that. One thing I forgot to do before this step, which we can do right now together, is you'll see there's a separate set of holes here on the Nano-Lift. These holes are actually to hard stop the end of the Nano-Lift so that you don't extend beyond that 18.5 inches. So to do this hard stop, what we're going to do, and I'm going to do one, but you can do it on all four just for this demonstration. If you have the plate at the end here, there'll already be a little bit of space, but if you don't have a plate, this is what you're going to have to do. So you're going to have to take a 6mm M3 screw, and then we're going to take a normal knot, not a thin knot. We're going to take two normal knots actually. You can sort of see the side-by-side difference here, hopefully. It's a very minute detail. If you're lost, just use a caliper. This is 2.4mm thick, and this is 1.6mm thick. We're going to use one of the nuts as a spacer. That's to sort of simulate this plate being here. There we go. It's effectively a shorter M3 screw. Once we've got this, we're going to use our nut tool again. We're going to screw into that nut directly. So as you can see, there's a nut there, and that hard stops the box tube, and it stops it from going past the point where the two nuts hit. So now that we've done that, we can take our spool and we can extend it to the maximum limit. And then while it's at its maximum limit, we're actually going to tie the return string. So I made it a little difficult for myself because the return string hole is on the other side, but we can kind of remember that location, and I'll give it a little bit of slack like this. And what we're going to do is we're going to wrap the return string around from underneath like that, and we're going to thread it through this top hole, and we should see it come out the side like that. And then once we've done that, we can retract the tube a little bit like that. You can see it's unspooled, so we'll try and pull it tight again. And we're going to do a knot. So when we do this knot, try and have it as close to the pulley body. So I do that by holding the knot like that. And as you can see, we've tied our two strings. Now it won't be super tight yet. As you can see, when I retract it, there'll be some slack, and that's expected. And that's what we're going to do now, is we're going to actually tighten our return string. See how the knot I tied, we could actually pull this much slack through still. I'm going to tighten another knot that's going to be closer again to the spool. Tying another knot now. Here's another trick, using an Allen key in the middle of the knot and then pulling it tight. And then once it's tight, removing the Allen key is a good way to do it. As you can see, it's a little tighter now, but what we'll do is slowly extend the nano tube again and then slowly retract it again. Be careful because we don't have the other side on yet. And yeah, as you can see, there's a little more slack, so I can pull it through, and I can probably do another knot. But that's the general idea of tensioning it. So yeah, taking our other plate and bearing, same thing as before, just gonna press fit it in. And for now, to hold everything in place, I'm going to use the square beams. There we go. So now both mounting plates are on. Not everything's tight yet, but as you can see, I can extend the box tube like that, and I can also retract the box tube like that, and everything is relatively tight. I'm going to actually grease the tube. So in this case, I'm using just silicone spray, and I'm going to spray it on the outside like this, where the bearings contact the tube. Same thing for the 10mm stage. If you want, you can spray some down there for the inner bearings to get some action as well. And yeah, that's made the box tube a lot smoother. Quickly, I'll show you tensioning it from this side. Find where your box tube string is the loosest. So it really depends where you mount this, but generally it's loosest at the bottom And what you can do is if you've left yourself a bit of an end, the best way I find to tighten it is to grab that end with pliers and sort of pull it up using the plate as leverage. So you can see the string getting pulled through the pulley like that. And this was our previous knot. So you can see how much I've actually managed to tighten the string down there. So for my case, I'm gonna undo these 2 screws to retension it, but you can probably have a more creative pulley design that allows a better way of tying this string off. It really depends on your setup, and hence why we've only provided a simple PLA 3D printed pulley. But you can add another clamping feature, for example, or use an M3 screw to tie off the string here. It all depends on your setup. Again, if you're not using a return string, you don't have to worry about any of this. But for me, what I'm going to do is I'm going to quickly undo these screws here, and then repeat the same process. Exactly the same process as before. Like that, that's good enough. And lastly, I'm just going to do up the rest of these screws for everything to be done. So yeah, that is our Nano-Lift fully strung. As you can see, driving the spool drives linear motion for the Nano-Lift, and you can kind of see how it works. So when I extend the string, the smaller pulley kind of reels in string, and the larger pulley releases string, and that's because we got a 2-stage kit. And then as I retract, it's the opposite. There's no RPM limit on how fast you can power the Nano-Lift. Another tip, if you're using a shaft like this, you can also coaxially drive this hex shaft. So you could have, for example, a rotating mechanism like this, where the box tube is also extending like that. As for mounting, I would recommend to make use of the threaded mounting block. As you can see, there's threads on the bottom as well as on the side. And I would recommend mounting directly to your base plate, as well as having structural supporting brackets that will help decrease the bending in your system. For this season, I would recommend mounting your Nano-Lifts very close to your robot center of gravity, as it isn't really designed to handle heavy bending moments. Me and the team here at Offset put a lot of effort into developing this kit, and we really hope you like it for both FTC Decode as well as other seasons. Make sure to head to our website, offsetrobotics.com, to check out new product releases such as these mounting gussets. Make sure you join our newsletter to get notified when new products come out. Hope you guys like your Nano-Lifts, and see you in the next one.